So domain and range of absolute value. These are the definitions that you've written down before in your notes. So if you flip back through all of your stuff, you'll find domain is all possible values for x. We just listed them out, and then we also said 1 is less than or equal to x, which is less than or equal to 3. Now, this only works if 1 is the lowest and 3 is the largest. If it could have been any number, then we would say domain is all real numbers, or all numbers. Range is all possible values for y. So 13, 21, 29. So 13 is less than or equal to y, which is less than or equal to 29. Again, these two numbers only work if that truly is the smallest and the largest number for range. So we're going to do it for absolute value. So that's just a review. Those notes, if you look back, I found them a minute ago, but if you look back, you should be able to see domain and range somewhere in your notes. I found it a minute ago. I should have marked it. I think I'm too far back. Oh, there it is. So we wrote it right here. All possible values for independent order x. Range is all possible values for y. So we listed them out, and then I showed you how to use inequalities. Like right here, you put the lowest number and then the highest number. So we have talked about this before. It's been a while. I don't remember when that was, but it's been a while. So if we do the parent function, so y equals the absolute value of just x, and we put our table of values, x, y, -4, -2, 0, 2, and 4. If I take the absolute value of -4, that's 4. Absolute value of -2 is 2. Absolute value of 0 is 0. Absolute value of 2 is 2. Absolute value of 4 is 4. So if we list out the domain, I'm just going to list them first and then we'll write our inequalities. So domain is -4, -2, 0, 2, 4. Now, those are the numbers that I've been telling you guys to pick. Could I, if I really wanted to, could I have done taken the absolute value of -5? Well, yeah, it would have been 5. Could I have taken the absolute value of +5? Yes. Could I take the absolute value of -100? Yes. Could I take the absolute value of +100? Yes. So if it can be any number, then you just say the domain is all real numbers. The reason you write the word real is because when you get into Algebra 2, you will start talking about imaginary numbers and other stuff. So you just say all real numbers. Because I could even take the absolute value of -1.5. I could take the absolute value of -2.2358432. It's any number, so domain can be any number. Now if we look at the range, let's go ahead and list those, is 4, 2, 0, 2, 4. Now, and you're always writing it for the equation that you're actually looking at. So if I look for this equation or this function, it's the absolute value of x. So the absolute value of every x value gives me the y. Well, do I have any y values that are negative? No. Could I have a 4.2? So if I use -4.2 as my x, could I have a 4.2 as my y? Yes. Could I have 0.5? Could I take the absolute value of 0.5 and get a 0.5 as my y value? Yes. But you cannot get, for this equation, you cannot get a negative y value. So you would say range, all of your y values have to be greater than or equal to 0. And remember, you put the or equal to because 0 is a possible value for y. So y values have to be greater than or equal to 0. And that's it. You just say the values have to be greater than 0 or equal to 0. Okay, I'm going to give you a graph. So that one is just giving you a table. If I give you a graph and say what are the possible, or what is the domain and range? So if I have this absolute value, notice where the vertex is. So notice it's not at the origin, it's shifted 1 down. So the first thing you want to do is list your domain for your x values. You don't have to do this step if you're understanding how to decide these parts, but in my opinion it's always easiest. So -1, -2, -3, -4, -3, -2, 0, oh, I forgot 1. -1, 0, sorry, that's a -1. 1, 2, 3. Now, that's all I have graphed. But is that all the graph would go? Would this keep going? Could I have a -5 as my x? Could I have a -6? Could I have a -7? Could I have a +4? Could I have a +5, a +6? Could I have a +100? You could. So again, the domain is all real numbers, because it can be any value. I can use any value for this equation and I would get some y value. Okay, let's go ahead and do the range. I'm going to again list them out just to help me think about it. So range, I'm talking about y values now. So I need to say 1, 2, 3, 4, 5, 6, 7. So I have 7. I have 1, 2, 3, 4, 5. I have 1, 2, 3. I have 1. I have -1, because again I'm looking along the y-axis. I have a +1. I have 1, 2, 3, and I have 5. Now those are just the points. So notice, what is the lowest value you see in all of those? Well, the lowest value is -1. So y has to be greater than or equal to -1. Everything, and I'm going to go ahead and draw this line to just show you, there are no points down here. Everything is up here. So that's why y has to be greater than or equal to -1. There is a y value up here. There's a y value up there. There's a y value there, there, and so on. So that's why the range has to be y is greater than or equal to -1. Okay, I'm going to do one more. I'm just going to extend this a little. Not really extend it, but I'm just making a new graph down here. Okay, so if I said domain, you can list out, I'm just going to actually mark them on the graph. So we have domain of -1, -2, and -3. -2, -3, -2, -1, 0, 1, 2, 3. Then think about, can you have more than that? Can I have a -4x value? Can I have a +4? Could I keep going this direction and there still be a part of the graph every single time? Yes. So again, domain is all real numbers. Okay, range. I'm going to mark the values. So I have 1, 2, 3, 4. I have values at 3. I have values at 2. I have values at 1. I have values at 0. I have values at -1, -2, -3. These would keep going. But notice there's nothing above that line. They're all down here. So I would have to say y, all of the y values, And then we know it's at a positive 1, 2, 3, 4. But here's my question. So the last one we said y is greater than or equal to negative 1 because all the values were greater than. Here it's at 4. Are all the values greater than 4 or are they less than 4? They are all less than because they're below it. So it's less than or equal to 4. So that's the difference between this one because it's upside down or it's got a negative a value and this one that opens up because it's a positive a value. So that's domain and range.